My name is Alec, and I am a student of the machine learning engineering class at Coder School in Ho Chi Minh City. My project is on detecting forced labor in the world's fishing fleet using deep learning. First off, what is forced labor? Well, according to the ILO, it's all work or service which is exacted from any person under menace of any penalty and for which said person has not offered himself voluntarily. So it's essentially forcing someone into a situation of labor under threat or coercion. This is a huge problem. Around 16 million victims of forced labor globally, and around 11% of those are in the agriculture, forestries, and fisheries. So what kind of situations do these kinds of people suffer? Well, for a start, having their wages taken away from them. Also having their documents taken away from them. So things like their passport and their ID, so that they can't leave the area they're in, or they can't access any kind of social security mechanism. And perhaps worst of all is restricted movement. So they're locked in the house they're working in, or the compound they're in, or the boat that they're working in. And can we use tech to solve forced labor? So a bit of background about myself. I work for an agency of the United Nations which deals with forced labor amongst other issues. And I think there's a real opportunity to use emerging technology, for example, machine learning, to leverage some kind of solution out of this. But the problem is there are two groups of people who are key to this, and I don't think they talk to each other enough. First group are these guys, the machine learning engineers, developers, statisticians, tech innovators, and others. And we'll call these guys the tech nerds. The second group, the policymakers, the development practitioners, subject experts, etc. The UN bureaucrats, in other words. So the reason I do this course is kind of as a proof of concept to see if the merger of these two groups yields anything meaningful and perhaps some kind of solution. So how can we detect forced labor in fishing boats with machine learning? So we use one of these. This is an AIS, or automatic identification system, which is on any fishing vessel over a certain size. What it does is it pings the location of the fishing boats to a satellite. And from that, we get one of these, which is a map of where the boat's gone and where it is going. So if we add these two things together, we have some data. What the University of California have done is they have got this data and amalgamated it into a bunch of different categories, including vessel type, number of encounters of each vessel, the maximum distance that boat fishes from shore, the engine power of that, if that boat switches off its satellite system, which can also be telling for these kind of offenders. The problem with this data set is that it's massively unbalanced. 125,000 boats were tracked over around the course of 5 years, but only 55 of those were offenders. So that means only 55 in the positive class. My plan to solve this problem is to use an autoencoder, which looks like this. It's a neural net which has a set amount of neurons on one side. The encoder side squashes it down to a small area in the middle called a bottleneck that blows it back up to the same amount of neurons that it started with. So what we do is we take our data in, only the negative class, and then we train it to be able to accurately replicate the data that we put in. Why is this important? Well, we're interested in this central section here. So if we've done this right, this central section can infer some kind of meaning, some kind of relationship about the data that we put in. We call this the hidden representation. So we chop off the end of the autoencoder, and then we're just left with the encoder. We then put in unseen data, maybe data of an offending boat. And then from that, we may be able to get new inferences out. Here is the model I used. The pipeline looks like this. I take the AIS data and I push it through the trained neural net, just the encoder section. And from that, I extract what's called latent representations. This is a TS&E chart. I'm just going to zoom in on this now. So what we have here is a chart which basically uses a mathematical technique to squash down multi-dimensional data into 2 dimensions so we can interpret it as humans. What I want to do is focus in on this section here. So the red dots are clear cases, 100% confirmed forced labor offenders. The green cases, however, are not necessarily confirmed non-offenders. Some of them, especially the ones which are grouped quite close to the red ones here, may be actually offenders, but they haven't been caught by authorities. They've only been caught by the autoencoder. The second part of the pipeline looks like this. So those latent representations, I then oversample them, and then I put them through a support vector machine classifier. And from there, I get a risk rating as a percentage, which is then put into a category from very low to very high. Let's see what this looks like. So this is the interface. I'm just going to bring up a map now. Bear with me as it loads. So what you can see here is the south coast of Wales. What I'm going to do is look for some fishing boat activity. The green circles here are recent fishing efforts. So let's click on this one. So what I'm going to do is focus on this MMSI number, which is a identifying vessel number. And I'm going to put it into my risk indicator and see if this boat is likely to have forced labor. So according to my model, this particular vessel has a very, very low chance of harboring forced labor, about 0.4%. Also, as you can see here, the interface has pulled up some additional information about this boat, its name, in this particular case, the GV resolution, where it currently is, and some additional information. So some scores. The classifier part of my model, I want you to focus on these scores here, specifically the recall score of 0.89. Recall score is very important in a model like this because a higher recall score indicates the model doesn't tend to assign many false negatives. False negative in my case would be a fishing vessel, which the model thinks is an offender, but it actually has been missed. So we want to keep these down to an absolute minimum. Just as a comparison, the University of California did a similar study on the same data set and got a random forest F1 score of 0.43. So my model, which uses deep learning, sees a 50% increase in that, which I'm quite happy with. So finally, bringing you back to this first slide, can we use technology to solve forced labor? Well, machine learning or AI isn't a panacea. It's not a be-all, end-all. It's not a solver of all problems. But through this example, I think I've proven that if it's used carefully and with insights from experts and, of course, survivors, there is a huge untapped potential to do good. Thanks for listening.